In a previous video, I was showing that I could type text within a 64K segment in my video memory. And I had commented that at some point I need to add logic so that I can be typing text and flow beyond a 64K segment into the next segment and really work anywhere in the screen and not have to worry about being stuck in a 64K segment at a time. I've added some logic to support that, and I thought I would walk through maybe my approach to this, and definitely looking for feedback if there's other ways that I should be thinking about this, but I'll at least share what I've done at this point. Let me go ahead and turn on my system, and you'll see the output that I currently have coming up. First thing I do is I clear both video frames. So again, I have two video frames here, frame 0, frame 1. Clear it with black, and then I put up just a loading message. And then once that loading message is up, I dynamically build this test screen. And the text that you see on it is placed dynamically. I then fill in every potential color of red within a rectangle from lowest to highest brightness. I then repeat that with green and blue. And then this pattern in the middle of the screen, I'm really showing every single possible combination of colors, which is again 2 bytes of color. I'm doing an RGB 565 or 5 red, 6 green, 5 blue. And that pattern is just basically a loop within a loop that's filling out all of the different potential colors. And then I have that little animated sprite that goes across the screen twice. I'm going to go ahead and reset it and let that run again. When this comes up and my 286 is wanting to work with all of that video memory, it has to set a register, and that's what these last 4 bits of this bar graph up here are showing, is which registers it's currently working with. Then coming left, there's the 5th LED from the right, which is showing which of these frames is actively being used by the VGA, or actually which of them is being used by the 286, and then the opposite is being used by the VGA. And I did notice on the previous video, the video doesn't pick up when that's flickering. In real life, in person here, I can see it switching between frames, but the video camera doesn't pick it up well enough. And then as a reminder, this first LED on the far left is just that the system's waiting for VSync before it switches frames. I'll do reset one more time. And there's the snow. I initialize it to black. I show the loading message. I dynamically then build this and bring it up, and then I run the sprite across the screen twice, once at 1 speed and then slightly faster the second time. Maybe a comment on the recording at this point. I did switch to a different device that I'm using to capture. Previously, I was going out of my VGA into an HDMI converter into an inexpensive HDMI to USB capture device. And I had forgotten I have a different device sitting around. It's an EVGA XR1 Pro capture device. So now I'm going out of the VGA into an HDMI converter, then into this EVGA capture device, which goes to USB-C in my computer. And I think that's going to do a little bit better job of picking up some of the movement, but we'll see what it looks like here after I come back and watch the recording of what it's capturing. So one last reset, and then I'm going to jump in and maybe talk about what did I put in place to make some of this stuff a little bit easier to work with. Because what I don't want to be doing is constantly dealing with which segment am I in or want to be in, and trying to then set the register to set the appropriate segment constantly. I kind of wanted to make that more of an underlying foundational piece of functionality that I can use, or abstract that a little bit from the rest of my code. So maybe what I'll take a look at here then is I'm going to jump into just this graphic I've shown before on the screen, where my 286 is accessing one of the frames, and then the other frame is used to output to the VGA, and I can swap back and forth. If I zoom into one of those frames for a second, I've got the 286 that needs to access, and that full frame is 1 meg, but the 286 is only seeing 64K at a time. And then I have these registers that I can rotate through, so that 64K window maps to different segments within the video RAM. What I want to be able to do, though, is not think of it in 64K segments and memory addresses. Instead, I just want to treat it like an XY coordinate. And so this is maybe what I could look at is the upper left is 0, 0, and then I can work my way across horizontally to pixel 1023 and vertically down to 511. So that's it's 1024 by 512, and I'm doing 2 bytes of color per pixel. So that's how I'm essentially logically thinking of my physical memory, and that is the full 1 megabyte. So every row, if I think of it as 2 bytes per pixel, to get to 1024 pixels, that's 2K of memory. Now what that means is for every 64K of segmented memory on my VRAM, that's 32 lines that really will allow me to fit this 1024 wide. 32 lines will be equal to 1 segment. Now I'm not doing 1024, I'm doing 640. And then vertically, I'm not going down to 512. I'm really only wanting 480 pixels. So I'm going to go down to 479. And then you can think of it maybe this way is how I've got this organized. Is every one of those 64K segments is 32 lines of screen content. And each of those 64K segments has 64K of addresses, of course, from 0 up to FFFF. And then each of them has a different register address. So register 000, that'll give me my first. I can go to 0001, and then I can go to 1011, 100, etc., and work my way down. And that will give me access to each of those 64K segments. But that gets to be a little bit confusing if I'm trying to draw, for example, a sprite or a rectangle or some text. How do I know that part of that sprite or rectangle or text is on one frame while another part is on a different frame? Well, to support all of that, I've gone in and maybe made a series of routines here, and I'll just walk through some samples, and maybe I can get this code posted if you're curious to dig into it deeper. And the same disclaimer I give out every time, I am not great at this assembly stuff. I'm just working on this, so don't take this as the best way or the only way or the right way to do it, but this is how I am currently doing this. So I have a procedure to draw a pixel. I have a procedure that will set my segment automatically given an XY position. I have another procedure that will return a memory address based on a given pixel coordinates XY. So if I give it an XY, it'll come back with an address within a 64K segment. And then I also have a draw rectangle that I put together. So for this test screen, I'm drawing lots of rectangles there. I'm drawing 32 different red rectangles, 64 green, and 32 blue rectangles. And I just have a simple little routine that helps draw a rectangle with a given color. And then, like I've shown in a previous video, I have a routine that swaps frames. So it swaps the VGA output from one frame to the other. And maybe if I jump into this draw pixel, here you can kind of see what I'm doing here. In this, I am really calling two procedures. So I have some variables that I can set, and there's 3 that I can fill in. I can fill in a variable called VGA param X, there's a VGA param Y, and a VGA param color. And these are kind of like they sound. At what position do I want to draw a pixel as far as X coordinate, the Y coordinate, and what 2-byte color do I want to draw with that pixel? And so I would first fill in those 3 variables, then I would call this draw pixel, and then it's going to call this VGA set segment from XY, and it will use that XY and then automatically update my register to be in the proper segment for that specified XY coordinate. And then I call another procedure, this get pixel mem address, and that again uses the XY coordinate and determines within the 64K segment for the selected register what is the address of that pixel. And it returns it into BX, so it comes back in my B register. Whereas the set segment actually updates my register on my video card. This one then returns an address that I can then reference. And then I come down here and I basically say, well, go ahead and go to my A0000. That's what these first couple lines do, is give me ES pointing to my memory from the VGA window on my 286. So my 286 sees the entire video card as A0000. And this says, okay, go to that. And then within that, jump to this offset basically of where that pixel is. And in that pixel, put in AX, which is the color that I had specified. So give me an X, give me a Y, give me a color. This will fill in that pixel with that color. And so that's how I can go to any pixel now on my screen and fill in a color on that pixel. Now to see what that set segment does, here's the code for that. So in this case, I want it to update the last 4 bits of my register, which tells it which of the 64K segments I'm using. And so I come in here and basically I've got a Y, the VGA Y param. So what is the Y position of whatever it is I want to work on? And then from that, it pulls out the appropriate bits and maps them and says, well, these 5 bits really, if we're talking vertical position, correspond to what the register should be set to. And it's really that easy. So I just say, grab those bits, and sorry, not 5 bits, it's 4 bits. So these 4 bits, basically what I do is I pull those out and then I shift over, so those are just low values. I then read in my register, ignoring the last 4 bits, and then I OR in what I want it to now be for my register, these new 4 bits, and I write it back to the register. So this just simply says, what's your Y position? Read in the register, set the bits for the segment according to the Y position, which 64K segment it should be in. And if I back up, that would then get my register set, but then I still need to get the 64K within it, the memory address that that pixel points to. And so if I step forward, this procedure, get pixel mem address, does that basically. And so if I have a given Y and a given X position, this is going to basically bring out or give me the memory address as B. So it's going to basically fill in my B register with the address. And you can kind of see the logic that I'm using here. You know, the first 5 bits are really telling me, are being filled in from Y, and the rest of the bits are being filled in from my X position. But this will give me the address in VRAM of this specific pixel within a 64K segment. And so this is a simple little routine that does that for me. So between the get pixel mem address and the set segment, that gives me the support to do this draw pixel. And then from there, I could do things like stepping forward to this draw rectangle. And here I've got a procedure that draws a rectangle. It's not great, but it's a start to a procedure that it is working at this point. And essentially, it's going to use, indirectly, it's going to use this VGA param color. It wants to know an X, it wants to know a Y for the start of the rectangle, and then it needs an X and a Y for the end of the rectangle. And right now, I'm going to assume that my ending is to the right and down. In other words, it's higher values than my start. So the end has to be greater than start, the way I've written this so far. But basically, if I say I want my start to be 0, 0, and I want my end to be 5, 5, what I want to do is fill in 0 through 5 horizontally and 0 through 5 vertically, and have that entire rectangle get filled in with whatever color is set in VGA param color. So then I go down into code, and being that was kind of a 0-based, let's say 0 through 5, I wanted 6 pixels. I actually quickly increment the end just so that my logic down here stops at the appropriate location. But basically I say, okay, give me my start of my X, Y, and for every row of that rectangle, go ahead and fill in the pixels for that row, and then move to the next row and do it again, move to the next row, do it again. So I start by putting in my rectangle start Y into BX. I put my rectangle start X into AX, And then I say draw a pixel there, and within that draw pixel, it's going to use the param color and draw it at that location. And then I'm going to increment AX, which is my X position, and that's moving me a pixel to the right. And then I simply compare, am I at the end of my X? So did I go as far right as I need to? If not, do it again. So it's going to fill in a pixel, move to the right, fill in a pixel, move to the right. So I'm basically filling in that first row of the rectangle left to right. Once I get done with all the rows, then I'll have met the end of where I should be. And then I go ahead and I say, well, okay, let's now go down to the next row. And so I increment BX, which is tracking my Y position. And I basically then fill in the entire set of pixels for that row, jump to the next Y, jump to the next Y, and just kind of repeat that process. So filling in a rectangle pixel by pixel for one row at a time, working through all the rows in that rectangle. And then once I get any changes done in my memory and I want to actually have it visible on the output, I have to make that frame visible, and that's where this VGA swap frame comes in. And I don't think I've changed this from the last video where I showed it, but basically it reads the register that says what is the full register, and then it basically does that read here, and then it flips this bit, which is which frame to use, and then it sends that register out. And then once it does that, that's told the circuit, I want you to flip your output frame. But the circuit right now, because of the logic I have in my PSOC, says don't actually flip the frame until I hit VSync. And so this here then just says keep checking from reading that register to see if that flip has actually happened, and don't continue until that does happen. And that'll make sure that I don't accidentally continue with additional writes to the memory while it's kind of in this in-between state of not having switched my frame entirely. And at some point down the road, I'm going to make that better by using interrupts instead of doing this polling, but that's what I'm currently doing, is this polling to get that done. Maybe what I can do then is show you how I built this test frame, and maybe let me just reset my system one more time so that you can see that one more time. So I'm going to hit a reset here. And again, I clear my two frames, I draw this loading text, and then up comes all of this other text. And if you look at this, the red, there are 32 different boxes there. There's 64 different green boxes or rectangles, and then there's 32 blues. And if I go over to the code for that, just to show you kind of what I'm doing there, I'm not going to go through it in super detail, but I will get down to here's my VGA draw test pattern procedure. And what I do in it is, I'm going to just point out some snippets of this, is I have support so that I have a variable called cursor pos H and V. That's a horizontal and vertical position in XY coordinates that I can set. And then when I call this procedure here that says print a message to the VGA, it's going to print whatever message is pointed to by BX, and it's going to print it at this position. So I print a header message, and that's the message that says dynamically generated test pattern. I then tell it to go to 250 for X, 75 for Y, and print in this message, which says red 0-31, 5 bits. And then I repeat that for the rest of the messages that you see on the test screen. Then I fill in all of the red rectangles, and this is my code that does that. So I want it to start drawing my red rectangles at 50-50. And then basically this code just says, okay, come in here. I want you to make a rectangle with the color of essentially starting out with 0. And that came from AX. And if I look at this, AX started out by bringing in SI and shifting it left 11 positions. But I bring that in, and then I work my way down through this, and I do increment SI. And then when I come back through the loop, SI is now 1, and then I say go ahead and shift that 11 left. The reason I'm doing 11 left is I'm doing 5 red, 6 green, 5 blue. So if I want this counter that's going to go to 1, 2, 3, 4, 5, 6, work its way up, I need to shift it into the position where the red bits are. And that's what the shift is doing. Shift 11 gets me into the reds. So this is just going to increment and create 32 rectangles, and each one is going to have one higher value of red. I then repeat the same process with green, starting at 50, 90. So go to x equals 50, y equals 90. And this time I go 64, and those are half as wide. And just work my way up through all of the greens. Then I do the blues. And then I do that full pattern that tries to get every combination on the screen of pixel colors. And this is just the routine I'm using for that. You can read through that, and if you have questions, let me know. And it's nothing really useful or very exciting, but at least for now, it lets me just get all those colors up on the screen. And then I get down to where I have my ship come across, and that's the same code as I had shown in a previous video where I was animating that sprite. But basically, I've got a procedure called call sprite, and in that procedure, it's going to move it across the screen. And in this case, it's going to go 3 pixels at a time, and then it's going to move it again across the screen 4 pixels at a time. And right now, that procedure I have not updated. So it's just basically saying go to a specific segment, and this is which segment I want it to be in, and animate it across and animate it across again. Later, when I want the ship to go and jump between segments, I'll have to update that code to actually use some of this previous work that I've done where it knows the pixel and can set the segment automatically. But for now, this is all staying within a segment and animating to the right. So that's the end of that procedure that fills in that on the screen. So maybe what's next? I probably need to make a procedure that lets me do things other than rectangles. If I want to do a line, I can use my rectangle procedure. I can just simply have x start and x end be the same, or y start and y end be the same, so that I can draw either a horizontal or vertical line. But I'm going to want to probably be able to draw lines at different angles, so I need to write a routine that does that. I probably should add a routine that lets me do circles, and then I need a routine that lets me do triangles. And if I think I get those pieces in place and can have those things happen at any angle or any rotation with different fills, I think that'll start giving me some nice pieces to be able to do more complicated vector type of graphics moving forward. And I've got to see what the overhead, there's a lot of overhead here to make this more transparent or abstract some of the complexity from me, the coder, in my assembly. So, if I say draw a pixel and it's got to then go figure out which segment and modify, my register and read registers and do all that stuff, that's overhead. Versus like that ship, it's just simply saying copy something from this location, increment it a little bit, do the copy again. There's less overhead to do that type of thing. So I'll see how this all plays out as I move forward. I got to keep in mind it is a 286, so it doesn't have a tremendous amount of horsepower, but we'll just see how well it does end up supporting animation and drawing screens and things like that. And maybe I can also point out at this point on the screen, if I hit escape, I can go ahead and clear, and actually let me reset the system real quick, and I'll bring this up, and then I'll do a clear of the screen once it comes up. I think I've got everything still supporting this. So this comes up, it's going to do my first pass of a sprite and a second pass of a sprite. And right now when this gets done, if I start typing, like I'll type in some cues, notice where it's typing them, because that's at the end of where it got done with some of my previous text. That's just where I left the cursor, if you want to think of it that way. But if I hit escape, it clears the screen, and now I can come in here and type hello world. Oops, hello world, if I can type correctly. This is a test. 1, 2. Now you'll notice now though, with some of these updates, I can go down as many lines as I want to go down, and I'm just working my way down here. And it really doesn't care about segments, things like that. I can just tell my code print a char, and I'm keeping track of my position, X, Y, where my char is. this is a test, and I'm just, oh, this is a test. So now I can just be working my way across, and you can see I can cover the full screen now as I'm working with this. More testing, if I can type more testing. Okay. And at the end of this, I've got a little bit of a buffer underneath the visible screen, and I've got a bunch of buffer off to the right of the screen that I can currently type into that you won't visibly be able to see. I do need to update my routine for print char and check for those boundaries and automatically wrap automatically wrap whichever direction as I go, I guess. But we'll come back to that later. So at this point, all of this seems to be working pretty well. I got my full screen. I can type. I can reset and get the full screen test pattern. And I'm getting a decent foundation now to maybe do something more useful with the system. But we'll see how this plays out here. So that's what I've got for now. I guess it looks like I'm at about half an hour into this recording, so I'm going to stop it here. As always, feedback, suggestions, questions, comments, always appreciated. And again, thank you to everybody that's constantly giving me feedback and suggestions and ways to make things better. I get feedback on the YouTube channel. I get feedback on my blog site, and some of you reach out to me via my email address too, and that's all very much appreciated. So thanks, everyone.